This video will try to understand the integration formulas which involves exponential functions. So, I guess during your pre-calculus, you have learned what is an exponential function, then what is its inverse, which is the natural logarithm. So, we will now give to you the formula which involves exponential function. So, the integral of e to the u du is equal to e to the u plus c. That is one of the formula. You have also the integral of a to the u du is equal to a to the u over ln a plus c, with a condition that a is greater than 0. So if you are asking why is it that the condition a is greater than 0 present in the second formula, because if a is equal to 0, then of course this term will be equal to 0. That is one of the reasons. So the question now is, how is this formula derived? So how does this formula came to be? So going back to your integral, let's say your differential calculus, I almost interchanged the two fields of calculus there. So going back to your differential calculus, so we have, what is the differential of e to the u? Let's try to write our u legibly. So e to the u. Okay. So what is the differential? So if you have your notes, you will just manage to recognize that it is e to the u du. Okay, so that is the formula. So of course, to get the integral, so we integrate both sides. So integrating both sides, so we have, so because integral or integration is the reverse of differentiation, so this side will just become e to the u. Okay. A to the u, while the other side will be the integral of e to the u du. And because like what we've done in our previous integration formula, because we are integrating indefinitely, so we must add c on this side. So e to the u plus c is equal to the integral of e to the u du. And there you go, your first formula is derived. So we'll try to derive the second formula. So we have what is the differential of a to the u? What is the differential of a to the u? So going to your formulas of differentiation, so we have is equal to a to the u ln a times du. So again, integrating both sides, so this side will just be equal to a to the u. Then because this ln a has no u, so it can be considered as constant. So ln a, we put that outside our integral. A to the u du. So by multiplying both sides with 1 over ln a, so this ln a here will be cancelled out. Then on this side we'll have a denominator of ln a. So we have a to the u over ln a is equal to integral of a to the u du. And since again this integration is indefinite, so we will add c on this side. So our formula now will become a to the u over ln a plus c. This is equal to the integral of a to the u d. And there you go, the derivation of the two formulas of integral which involves exponential function. So on the next video, we will solve an example of these formulas wherein we could apply this formula. So see you on the next video.